In this video, we will explore the concept of shift registers, key components in digital circuits that store and transfer data bit by bit. Shift registers are widely used for data storage, data transfer, and even for converting data between serial and parallel formats. We will delve into their types, how they operate, and their practical applications in digital systems. Shift registers are sequential logic circuits used for storing and shifting data. They consist of a series of flip-flops connected in a chain where the output of one flip-flop becomes the input of the next. Data can be shifted in or out one bit at a time, either to the left or the right, depending on the design of the shift register. Shift registers are typically classified into four types based on their input and output configurations. Serial input, serial output. Data is shifted into the register one bit at a time and shifted out in the same manner. Serial in, parallel out. Data is shifted serially, but once loaded, it can be accessed in a parallel from all flip-flops simultaneously. Parallel in, serial out. Data is loaded into the register in parallel all bits at once and then shifted out serially. Parallel in, parallel out. Data is loaded in parallel can be read out in parallel, making it faster for certain operations but less commonly used for shifting data. A serial in, serial out shift register is a type of shift register where data is input and output one bit at a time in a serial fashion. It is commonly used for data storage, data transfer, and digital signal processing in various electronic applications. Suppose you have a 4-bit serial in, serial out shift register and want to input the binary sequence 0101 and the first clock pulse 1 is shifted into the first flip-flop and the second clock pulse the 1 shifted to the second flip-flop and another 0 is shifted in. This process continues until all 4 bits have been entered. As additional clock pulses are applied, the data shifts out 1 bit at a time through the output terminal. In a serial in, parallel output shift register, data is fed into the register 1 bit at a time serially and is then outputted all at once as a set of parallel bits. It is common type of shift register used when we need to convert serial data into parallel format. Data is inputted one bit at a time through a single data line. Usually, the input is fed into the least significant bit position. A clock signal is used to synchronize the shifting of data. With each clock pulse, the data in the register shifts by one position, moving the previous bits to the next position. After all bits have been inputted serially, the contents of the shift registers are available simultaneously on all the output lines. A parallel in, serial out shift register is a type of shift register that allows a data to be loaded in parallel and then shifted out one bit at a time in serial manner. This type of shift register is particularly useful when you have multiple bits of data that need to be transferred sequentially over a single data line, reducing the number of connections required for communication. The input data is loaded into the shift register parallel. Each bit of the input data is placed directly into one of the shift register flip-flops simultaneously. A load signal is used to control when the parallel data is loaded into the register. Once the data is loaded, the shift register can shift the bits out one by one, starting from the most significant byte or the least significant byte, depending on the design. A clock signal is used to control the shifting operation. With each clock pulse, the register shifts out one bit to the output. As the clock pulses are applied, the data is shifted out through a single output line, which is why it is referred to as a serial out operation. Parallel in, parallel out shift registers are digital circuits that handle multiple data bits simultaneously. Unlike serial shift register, where data is loaded or read one bit at a time, parallel in, parallel out shift registers load and output all the bits at once. Here is a brief overview of how the parallel in, parallel out shift registers work. Data is loaded into all the flip-flops registers simultaneously using parallel input lines. This means each flip-flop in the register receives unique bit from a set of input lines. After the data is loaded, it is also read out simultaneously through parallel output lines, make the output process very fast. Like other type of shift registers, parallel in, parallel out shift registers use a clock signal to synchronize the loading of the data into the flip-flops. Some of the applications of shift registers are shift registers serve as temporary storage devices for digital data, allowing for the temporary holding of binary information. This capability is essential in various applications including buffering data during processing and holding intermediate results. Shift register facilitate the transfer of data between different parts of digital circuit. By shifting data in a specific direction, they enable manipulation of binary information such as bitwise operations, arithmetic operations, which are fundamental in digital signal processing. Shift registers can be employed to create time delays in digital circuits. Serial in, serial out, and parallel in, parallel out shift registers are often used to introduce delays in signal processing applications, allowing for synchronization between different components. Data conversion, serial in, parallel out shift registers. These are crucial in communication system where data needs to be demultiplexed. Serial parallel in, serial out shift register converts parallel data into serial form, making them useful in applications where data needs to be sent over a single channel. And finally, shift registers are widely used in digital communication systems for tasks like encoding and decoding data. They facilitate the transformation of data formats, enabling effective communication between different digital devices. Thank you for watching.